Every image and video you're looking at has been artificially generated by an AI, based solely on a brief, one-sentence instruction. This technology, developed by OpenAI, the creators of Chatgpt and DALL-E 3, enables the creation of vivid scenes ranging from human figures and urban landscapes to animals, natural vistas, and even otherworldly planets. Users can specify intricate details such as the setting, attire of characters, or the intensity of a dust cloud trailing a moving vehicle, virtually any scenario imaginable. Welcome back to Mind Polish, where we talk about a multitude of different intriguing topics from tech and science to business, economics, and even history and religion. If you're new here, make sure to subscribe to be in the know. Let's see what the world of AI has for us today. This AI, known as Sora, excels in producing these visuals rapidly and with astonishing realism. Sora represents the forefront of AI capabilities, capable of turning simple text prompts into detailed, unaltered visual narratives. These demonstrations aren't just the best pics, they were created in real time, highlighted by Sam Altman's live tweet sessions during Sora's launch. This interaction showcased Sora's ability to materialize user requests on the fly, with outputs shared immediately on social media, emphasizing the technology's real-time execution and impressive outcomes. We're at a pivotal moment in the evolution of AI-generated content, transitioning from easily identifiable AI creations to more sophisticated and nuanced visual outputs. While minor anomalies or fluctuating textures might still be noticeable, the overall quality of the videos has significantly improved, achieving greater realism where needed and enhanced creativity for animated styles. This marks a significant advancement in the technology's capability to produce lifelike and imaginative content. I believe it's crucial to highlight that we are moving beyond AI-generated videos that were easily identifiable to something more refined and complex. The distinction is becoming subtler. While you may still notice occasional quirks or inconsistencies in texture, the overall quality of the videos has improved significantly, achieving more realism where it's needed and a greater level of creativity and detail in animated styles. Another significant advancement is the ability to produce longer, seamless videos that maintain coherence throughout, videos that give the impression of being captured in a single continuous shot from one location, akin to drone footage. OpenAI mentions that they are educating AI to grasp and replicate the dynamics of the physical world, aiming to develop models that aid in solving real-world challenges through interaction. We're introducing Sora, our innovative text-to-video model capable of creating videos up to a minute long without compromising on visual quality or the accuracy of the initial prompt. Sora is now being made accessible to red teams for identifying potential harms or risks, as well as to a select group of visual artists, designers, and filmmakers. This initiative is aimed at collecting valuable feedback to refine the model, making it more beneficial for creative professionals. By sharing our progress with the community and seeking input from those outside OpenAI, we aim to offer a glimpse into the future possibilities of AI technology and its capabilities. Sora has the capability to craft detailed scenes featuring multiple characters, varied movements, and precise elements of both the foreground and background. It goes beyond merely following user prompts, understanding the real-world context of these requests. With its advanced language comprehension, Sora can interpret instructions dynamically, creating characters that display a range of emotions vividly. Sora supports the creation of videos with multiple angles or scenes, maintaining consistency in character depiction and the overall aesthetic. However, the model does face certain limitations. It might not perfectly replicate the physics within complex scenarios or fully grasp cause and effect relationships, for instance, failing to show a bite mark on a cookie after it's been eaten. It could also get confused with spatial directions in a prompt, like mixing up left and right, or accurately tracking a specific camera movement over time. Operating as a diffusion model, Sora begins with a base layer resembling static noise and progressively refines it into a clear video through several steps. This process allows for the creation of complete videos in one go or the extension of existing videos by anticipating multiple frames ahead. We have addressed the issue of maintaining consistent subject identity, even when it temporarily exits the scene. Employing a transformer architecture similar to that used in GPT-4 models, Sora achieves enhanced scalability. Videos and images are broken down into smaller data units, or patches, comparable to tokens in the GPT framework. This unified data representation enables the training of fusion transformers across a broader spectrum of visual content, accommodating various lengths, resolutions, and formats. Sora advances the groundwork laid by DALL-E and GPT models, incorporating DALL-E 3's technique of creating detailed captions for visual training data. This allows Sora to more accurately interpret and execute text-based instructions, producing videos that closely match user requests. Beyond generating videos from textual prompts alone, Sora can animate still images or enhance existing videos by adding or completing sequences. This technology is a stepping stone towards developing models capable of understanding and mimicking the real world, a crucial step towards achieving artificial general intelligence, AGI. A detailed paper on Sora is slated for release later today, offering an in-depth exploration of its mechanics. From a personal perspective, the evolution of AI video technology excites me for several reasons, particularly for the creative autonomy it offers artists. Currently, the film industry's output is heavily influenced by its financial structure and decision-making bodies, which often results in uninspired content. However, innovations like Sora, along with tools like 11 Labs that can replicate any voice, promise to revolutionize content creation. They enable the production of cinematic quality work akin to Pixar, Disney, or DreamWorks, powered by individual creativity. Whether you're a voice talent capable of bringing characters to life, a writer crafting narratives, or in need of inspiration for character development or story ideas, tools like Chatgpt are enhancing these creative processes, making high-quality, personalized content creation more accessible than ever. AI video was the missing link in achieving a more seamless digital reality. Initially, AI-generated videos were fraught with inconsistencies. Characters would change appearance mid-scene, sometimes even altering their clothing as they moved. However, the technology has made significant strides towards consistency and coherence. For instance, in a video where a woman walks through the streets of Tokyo, the entire minute-long sequence maintains a consistent backdrop as the camera follows her, showcasing what's known as temporal consistency in AI research. Essentially, the scene remains logical over time. The potential for creativity with such technology is immense, yet there's a less discussed aspect of AI video and neural networks at large that's equally fascinating. Research in this area, like that being pursued by Runway ML, suggests that neural networks are developing an understanding of the world that goes beyond their training data. They're beginning to comprehend aspects of reality they haven't been directly taught, inferring knowledge from the data they've been fed. This inferred understanding allows them to replicate real-world phenomena with surprising accuracy. For instance, AI videos that depict birds interacting mid-flight suggest that the network has developed a rudimentary understanding of physics and aerodynamics. Similarly, these networks appear to grasp concepts of lighting and perspective. A study highlighted on this channel demonstrated a neural network, built on the GPT architecture similar to those used by OpenAI, being trained exclusively on 2D images, without any 3D contextual data. Despite this, the network began to interpret these images as representations of three-dimensional objects. This suggests that, even without direct experience of 3D space, the AI developed an understanding of it through 2D images alone, challenging our assumptions about how neural networks perceive and recreate the complexity of the world around them. During their investigation into this model, researchers effectively paused its operations to dissect its processing, akin to a detective analyzing evidence without complete transparency into the neural network's internal mechanisms. They deduced that the model gradually constructs a conceptual understanding of three-dimensional space, distinguishing between elements in the foreground and background, and recognizing how light interacts with objects within a scene. It identifies the primary focus of an image, such as a car on a lawn, ignoring less relevant details like blades of grass and concentrating on the main subject. This capability doesn't stem from explicit programming by computer scientists but emerges from the GPT architecture and transformer technology powering these neural networks. By feeding them vast amounts of data, these networks enhance their ability to predict outcomes across various formats, images, text, or video. With more data, greater computational power, and sophisticated training techniques, their proficiency in rendering realistic outputs continues to evolve. Consider the images produced by this technology. Unlike video games crafted pixel by pixel through coding, these visuals are not directly programmed. Instead, text inputs guide the AI, which then undergoes training with human feedback to refine its performance. This process, known as reinforcement learning, enables the neural network to learn and adapt, effectively acting as a digital brain that simulates aspects of human understanding and creativity based on extensive exposure to human-generated content. The creations you see are the result of this digital brain absorbing and analyzing a vast array of human-made videos, then applying its learned model of the world to generate similar content. This approach highlights the AI's capacity to develop an internal representation of how the physical world operates, an area ripe for further research to uncover the depths of its understanding and potential applications. If you're wondering whether these examples are just the best picks and if you'll be able to achieve similar results, consider this: Sam Altman committed to creating on-the-spot responses to the diverse and complex prompts sent his way on Twitter, encouraging users to challenge the system with intricate and detailed requests. It's up to you to evaluate. Take this example: a wizard clad in a blue robe adorned with white stars, launching lightning from one hand while clutching an ancient book in the other. The result is quite impressive, with the wizard's face displaying remarkable realism, despite some oddities, convincingly portraying a spellcasting sorcerer. Or consider the whimsical image of a creature that's part duck, part dragon, soaring against a sunset backdrop with a hamster decked in adventure gear riding on its back. The fusion creature, complete with dragon-like horns and scaly green wings, is intriguing, even if its flight direction raises questions. Imagine a futuristic drone race taking place at dusk on Mars. The depiction captures the Martian landscape's iconic red hue, showcasing a competitive scene with various drones in action. It's an engaging visual that nails the concept. Visualize two golden retrievers wearing headphones, seemingly hosting a podcast from a mountain's peak. Their appearance is strikingly lifelike, adding a charming twist to the scenario. Picture an instructional video on making homemade gnocchi, led by a grandmother influencer in a rustic Tuscan kitchen, bathed in cinematic lighting. The scene blurs the line between gnocchi and mashed potatoes but remains visually appealing. Envision a bicycle race across the ocean's surface, featuring animals like penguins, sharks, and dolphins as competitors, captured from a drone's perspective. It's a challenging idea brought to life with creativity. Then there's the Bling Zoo, a unique video showcasing animals interacting with jewels, a concept as dazzling as it is perplexing. The sight of creatures engaging with diamonds and possibly choking on them is as bizarre as it is fascinating. Lastly, an emerald-adorned turtle, initially prompted in a confusing manner, as an animal eating diamonds, turns out to be a visually captivating concept, blending luxury and fantasy in a single frame. Just magical. It also has diamond-adorned legs. These examples underscore the technology's evolving capability to turn even the most imaginative ideas into visual realities. As exciting as these developments are, they hint at a future where the boundaries of creativity are continually expanded. Stay tuned for more, and don't forget to like and subscribe to keep up with the latest in AI-driven content creation.